Hello, teacher. Hello, students. Welcome to our first lesson on the graphs of polynomial functions. In our last few lessons, we learned how to find the zeros of a polynomial. Today, we will learn to graph the functions of polynomials. We will also learn the properties of the graphs of a polynomial function. If you're ready, students, we will get started. Let us begin today's lesson with a review. In grade 9, you studied the properties of the graphs of different functions. Can you remember the properties of the graph of a constant function? How about a linear function or a quadratic function? With a partner, please take a moment to sketch an example of each function's graph.
Students, let's get ready. Time's up. Let's get back to our lesson.
Welcome back, students. Were you able to remember the properties of each graph? A constant function is graphically expressed as a straight line that runs parallel to an axis, like this. For example, the constant function f of x equals 3 is rendered as a horizontal line that intercepts the y-axis at 3. A linear function is also a straight line, but unlike a constant function, the line may intercept the x and y axis at any point, and therefore lie at an arbitrary angle. The linear function f of x equals x minus 2 intercepts the x-axis at 2 and the y-axis at -2. A quadratic function is illustrated as a curved line called a parabola. The quadratic function f of x equals x squared minus 3 looks like this. Notice how it intercepts the y-axis at -3, but does not correspond to an integer on the x-axis. Do your graphs have the same properties as these, students? If so, great job! Now, let us learn how to sketch the graphs of even higher degrees of polynomials. Here's a polynomial called a cubic function because the leading variable has a degree of 3. This function can be written as y equals x cubed plus 2x plus 4. Students, make a table of values to graph this function. If you have extra time after you fill in each cell, try graphing other points between integers, like 1/2. You can get started right away.
Students, let's get ready. Begin. Time's up. let's get back to our lesson.
Hello again, students. Here is the table of values. If x equals 0, then y equals 0 plus 0 plus 4, which equals 4. If x equals 1, then y equals 1 cubed plus 2 times 1 plus 4. This is 1 plus 2 plus 4, which equals 7. If x equals 2, then y equals 2 cubed plus 2 times 2 plus 4. This is 8 plus 4 plus 4, which equals 16. If x equals 3, then y equals 3 cubed plus 2 times 3 plus 4. This is 27 plus 6 plus 4, which equals 37. If x equals -1, then y equals -1 cubed plus 2 times -1 plus 4. This is -1 minus 2 plus 4, which equals 1. If x equals -2, then y equals -2 cubed plus 2 times -2 plus 4. This is -8 minus 4 plus 4, which equals -8. If x equals -3, then y equals -3 cubed plus 2 times -3 plus 4. This is -27 minus 6 plus 4, which equals -29. You might also have plotted the value of x between integers. For example, if x equals 1/2, then y equals 1/2 cubed plus 2 times 1/2 plus 4. This is 1/8 plus 1 plus 4, which equals 5 1/8. Now we're ready to graph our equation. Students, draw a graph with an x-axis and a y-axis like this. Then plot every point that you have calculated on your table of values. When you have finished, draw a line to connect every point in a smooth curve. Notice that our y values are much greater than our x values. So our y-axis needs to be larger as a result. This should only take you a moment, so I'll be right back.
Students, let's get ready. Let's get back to our lesson.
Have you finished, students? Here's my graph. As you can see, if x is 1, then y is 7. If x is 2, then y is 16, and so on. Next, we must make a connecting line between each point of the function. Does your graph look like this one? Good job. What do we notice about the graph of this function compared with the graph of a quadratic, students? That is correct. The function that we plotted has 2 turning points instead of the 1 turning point of the quadratic function. We have discovered a rule that will help us graph polynomials. The graph of a polynomial function of degree n has at most n minus 1 turning point. Therefore, our third degree polynomial must have 2 turning points. This rule will prove very helpful during the next lessons when we learn even more about how to graph different polynomials. That is all the time we have for today, students. We have learned how to graph a cubic function, and we have discovered an important rule about the shapes of polynomial graphs. Until next lesson, thank you, teacher, and thank you, students.